this column.
Look, I wanted to say, I guess, one thing that I like about KenKen, TomTom, is that working the puzzle secretly drills your arithmetic facts. And it drills them in a sort of an interesting way. I mean, maybe the kids have memorized that 7 times 9 is 63, but if you have the opposite problem, what two numbers multiply to give 63? That's a, well, maybe it's 21 and 3, or maybe it's 7, or especially for addition. What three numbers add to give 10? There's a lot of different, let's say 3 numbers between 1 and 6, if you have, let's say, a 6 by 6 puzzle. And there are a lot of different possibilities. So you have to think about that. You have to think about factoring, and it turns out you'll have to think about a lot of other mathematical things, and we'll find a whole bunch of those mathematical tricks that get used. If you think about Sudoku, it looks sort of the same. You're putting in numbers 1 through 9, but there's no arithmetic involved at all. I mean, you could have just 9 different letters or 9 different symbols, because all you care about is not having the same symbol duplicated in a row, column, or one of those blocks. Here, there's arithmetic all the time, so you're drilling arithmetic as you're solving the problem. Okay, so let's take a quick look at this one. What sorts of things, well, there's one easy one. I'll put the 3 in, that's free. So everybody should be able to get that far. So can somebody tell me just an easy idea here to get started? 2 times. What do you know about that? So you got a 1 and a 2 here. Okay? That means, what do these two have to be? 3 and a 4, right? Okay? Can you decide anything about which one's a 3 and which one's a 4?
Well, the 3 is in a row, so the 3 has to go in the top.
Yeah, you couldn't have a 3 here, because there's no 0. You can't subtract 0 from 3. So the 3 can't possibly go here. That means the 3 has to go here, and that means there'll be a 4 here. So that's a start here. So what did we say? This will be a 4, right? And this one will be a 3. And that tells us the number below, since the only way you can get a 3 subtract from 4 is to put a 1 here and a 4 here, because 3 plus 4 is 7. And now we get an automatic 2, because we have to have a 1, 2, 3, 4 in every row. So we got to have a 2 up in the... Can people see the cursor here so I don't... Yeah, that's fairly clear. Okay, so we have to have a 2 here. Okay? That forces the top 2, a 1, 2. Since we've got a 2 in this column already, we can't have another 2 in that column. So the 2 has to go up here, and the 1 has to go here. So that's, so far, so good. What's another idea?
Oh, so once you have that 2 in the 7 plus box, you know that the other 2 numbers have to be a 4 and a 1.
In the, which?
In the 7 plus little...
This... Oh, the L thing. Yeah. 2. So so there's 7. So the next 2 numbers have to add to 5.
Right, it has to be 4 and 1.
Well, it could be 4. You see what she's saying?
It could be 2 because you already have a 2.
Right. Okay. Good. So does everybody see this? We've got 2 in this little L-shaped thing that sums to 7, and we've got 2 of them already. So the last 2 have to add to give 5. And so with the numbers 1 through 4, there's 2 different ways to do it. It could be 1 and 4, or it could be 2 and 3. But so it can't be 2 and 3, because the 2 is eliminated in both columns by things above. So we know this is a 1 and a 4, right? And we know that the 1 can't go here. So there's the 4, there's the 1, and now you get some free ones. You know that has to be a 4. All I'm doing here is completing the 4th number in each column. And then 3 and 4 is 7. We need 2 more to give a 9. That means the missing number is a 1. And now we just fill in. And it's a good idea to check to make sure we didn't, that it checked it for us.